All right, let's jump right in. If you're a developer who loves the raw power of C++, but, wishes you could tap into its massive ecosystem without all the usual headaches, then you're going to want to hear this. We're going to be talking about a new systems programming language called Pax, and it has one very specific game-changing feature that just might solve a huge problem for anyone working with C++.
So here's our game plan. First, we'll set the scene and talk about why using C++ libraries from other languages can be such a pain. Then, we'll properly introduce Pax and dive into its pass-through superpower. After we see that in action, we'll explore some of its other modern features and wrap things up by looking at the developer tools. Sound good? Let's get into it.
Okay, so first up, let's really nail down the challenge that Pax was created to solve. And trust me, it's a problem that many of you have probably felt firsthand.
I mean, think about it, right? C++ has this incredible universe of high-performance libraries for literally everything. Graphics, machine learning, scientific computing, you name it. But what happens when you try to use one of those amazing libraries from another language, like Rust, C# or Python? Well, it's usually a complete nightmare. You're stuck writing these complex foreign function interface bindings, that's FFI, or creating wrapper code and wrestling with things like name mangling. It's just a huge, frustrating barrier to entry.
And that brings us to the main event. If all that FFI friction is the problem, then Pax is the proposed solution. And it's a really direct and honestly kind of beautiful one.
So what is Pax exactly? Well, at its core, it's a systems programming language that's inspired by the really clean, structured, and readable syntax of languages like Pascal and Oberon. But here's the big twist. It doesn't compile directly to machine code. Nope. Instead, it takes your Pax code and transpiles it, or converts it into modern C++23. It even uses the Clang compiler bundled with Zig to do all the heavy lifting. And this one design decision is the key to everything.
And this quote from the documentation just says it all. This is the single most important thing to understand about Pax. The compiler is designed to know two things: Pax syntax and, well, everything else. If it sees code that isn't valid Pax, it doesn't throw an error. It just assumes, hey, this must be C++, and passes it straight through to the final output, untouched. This simple rule is its superpower.
So, let's see how that one simple rule creates something so incredibly powerful. We're going to look at what this pass-through idea actually means when you're writing code.
Check this out. This is not a C++ file. It's a Pax source file, and yet you can write a standard C++ #include directive right in it. There's no special syntax, no import wrappers, nothing. You just include the C++ header you need, and it just works. And because you've included that header, you can now use the types from it directly. I mean, look at this. We're declaring a Pax variable called v, but its type is std vector int. That's native C++, just living there, happy as can be, inside a Pax source file. No FFI, no binding generation, it just works.
And this right here is the final crucial piece of the puzzle. Once you have a variable that has a C++ type, you can call its methods using the same dot notation you would in C++. This line, v.pushback of 10, is happening inside a Pax function, but it's operating on a C++ object. This is that seamless interop that Pax promises.
Okay, I know what you're thinking. This sounds a little too perfect. What about when syntax clashes? For instance, Pax has its own new for allocating its own types, which is different from C++'s new. And what about C++ casts, like reinterpret cast? Those angle brackets could easily be confused for a less than operator. So how does Pax handle these potential mix-ups?
The solution is an elegant little escape hatch, the CPP function. As you can see here, for most things, calling functions, using types, that automatic pass-through works like a charm. But for anything that could be ambiguous, like C++'s new and delete, or those complex casting operators, you just wrap it in CPP. This basically tells the compiler, hey, don't even try to parse this. Just treat everything inside here as pure verbatim C++. It's a simple, predictable way to solve any conflict.
Now, it's really important to know that Pax is way more than just a clever trick for talking to C++. It's a complete modern language in its own right, with a whole bunch of features that draw from its Pascal roots.
And you can really see that here. This is not just some thin wrapper. You get all the modern conveniences you'd expect, like dynamic arrays and managed strings, but it also has serious features for real systems work, like C-compatible unions for when you need precise memory layout,
a unit testing framework built right in, and robust structured exception handling. It's the whole shebang.
A really crucial point about Pax's type system is that it's predictable. You know how in C an int can be different sizes on different computers? Pax avoids that mess completely by using explicit, fixed size types like int32 and float64. This means you always know the exact memory layout of your data, which is absolutely essential for systems programming, and for making sure you can talk to C and C++ libraries without any nasty surprises.
All right, for our final section, we're going to look at something that is, frankly, one of the most important parts of any new language, the tooling. Because a language can have the best features in the world, but if it's a pain to actually use, it's not going to get very far.
And Pax really delivers here. It has a full-featured language server protocol, or LSP, implementation. That means you get all the modern IDE features you're used to in whatever editor you love, whether it's VS Code, NeoVim, or something else. We're talking real-time error checking, smart code completions, go-to-definition, symbol renaming, auto-formatting, all of it. It feels like a professional-grade experience from day one.
And the great tooling doesn't stop in the editor. Pax also gives you source-level debugging. How? Well, because it compiles to C++, it can add special directives that map the generated C++ code back to your original Pax source. This lets it leverage the full power of the LLDB debugger, so you can set breakpoints, step through your code, and inspect variables, all while looking at your clean.pax files.
The way this works is just so incredibly elegant. You don't have to fumble around with the UI. You just write a $breakpoint directive right in your code. That's step one. The compiler sees this, and after it builds everything, it creates a separate little .breakpoints file. This file is just a map that says, hey, line 42 in the Pax file corresponds to line 350 in the C++ file. Then the debugger just reads that file before it starts and tells LLDB exactly where to pause. It's a simple, brilliant, and really robust system.
So when you put it all together, what do you have? Pax offers the clean, readable, structured world of a Pascal-like language, which is designed to make code easier to write and maintain. But it combines that with a direct, frictionless pipeline into the entire high-performance C++ ecosystem. It really does feel like it's aiming for the best of both worlds.
And this brings us to one last, really interesting question to think about. We often think about new programming languages as a way to get away from C++, but Pax completely flips that idea on its head. It suggests that maybe, just maybe, the best way to leverage the incredible power of C++ is by writing in a different, cleaner language that treats C++ not as a competitor, but as its ultimate superpower. It's a fascinating approach, and it's one that could really change how we think about interoperability.